So I made a video a little while back about the Pythagorean theorem, okay? Today, my objective is just to show you how this theorem works. I'm not going to derive it. There are plenty of history videos to show you how to derive it. So this is simply just how you can apply this skill. The Pythagorean theorem, and I say I'm not going to tell you the history of it, it's really hard not to. There's a guy, his name was Pythagoras. He was a cool Greek dude. I'm going to say he's a cool Greek dude. But him and his buddies, his clan, they love to find different harmonies and different ways of explaining the world. It's kind of like modern day hippies. Maybe I'd go that far. But basically, they found amazing relationships here with right triangles. Okay, a right triangle is one that has a 90-degree angle. And if you think about in Egypt, pyramids have really straight sides and they're made really particularly, and it's because of some of the mathematics behind these right triangles. Look at any ancient civilization and you'll find that mathematics is embedded in architecture for all of them. And even modern architecture and physics uses the same stuff. Okay, and when you get into deeper mathematics like in geometry, high school geometry, this is a really key thing that you need to understand. So let's start out with this simple piece. Okay, so the Pythagorean theorem says that if I take my right triangle, the two sides that have the right angle in between them, those we would call legs. And this side that is directly across, I'll do, what color should we do? Let's do yellow. The side directly across from the 90-degree angle, we call that the hypotenuse. All right, hypotenuse. And forgive me for not spelling it correctly. Hypotenuse. All right, hypotenuse. Okay, so the side directly across the hypotenuse. This will be and always is the letter C in the Pythagorean theorem. Okay, A and B don't matter. It could be either way, and that's because of the commutative property of addition. 2 plus 3 is the same thing as 3 plus 2. It's 5 no matter which way you add them. All right, so let's crack on. Let's try this, okay? 4 and 3, I'm going to substitute in for A and B. So 4 squared plus 3 squared equals, I have no idea what that side is squared. Okay, that's the hypotenuse. When you square it, we get 16 plus 9. Okay, that becomes 25. And the only way to get this to where C is not squared is you have to take the square root of both sides of your equation. Okay, so on both sides I took the square root. It is allowed. Okay, that is a property we can use. We can use the same operation on both sides and we would get exactly the same thing, same bounds. So this, we know the square root of 25 is just 5. Okay, and so this would be the length of that hypotenuse side right there. Okay, this is nice and easy, especially when you're given both legs. But pay attention, because in the next problem over here, they don't give us both legs. They give us one leg, and we do not know what this side is. We can call it A, call it B, but we definitely aren't calling it C, because C is reserved for my hypotenuse, okay, which is the side that goes directly across from that 90-degree angle. All right, C, that's 10. All right, so let's call this B, just because I want to call it B. Let's call it B. All right, if you want to call it A, that's fine. You just do your own thing, that's fine. But we're going to do B. So this is going to be 7 squared, and this is going to stay B squared, and this is going to be C. That's 10. So I'm going to substitute that in. Okay? And I know what that is, so this is 49. And I know what B squared is, and this is 100. Okay? So it's an equation. We're just going to solve it. So we're going to subtract 49 to, well, technically we're subtracting 49 from both sides of my equation. If I subtract 49 from here, that becomes 0. And if I subtract 49 from here, that becomes 51. But just for the sake of showing you, I'm going to subtract 49 and subtract 49. And I ran out of room, so forgive me, I'm just going to continue my work right here. So this is going to be B squared is equal to 51. And again, I don't know what that side is until I take the square root of both. So I'm going to take the square root of B squared, and I'm going to take the square root of 51, and I'm going to get B is equal to the square root of 51. And that's where I'm going to stop. Okay, so if you want to know, because square roots are always going to happen, sometimes you just have to leave it that way. Sometimes we can simplify the square root, and that is in a different video. It's called Simplifying Radicals. You should check that out. It comes after this. So see if you can kind of process this. I gave you 2 different examples that you can use, and yeah, we'll see you on the flip side.